Welcome to the next video in the Boswell's College Maths Induction playlist. In this video we're going to be taking a look at two things. We're going to be taking a look at finding the gradient of a straight line and also looking at finding the distance between 2 points on a graph, which is really just basic Pythagoras. So the gradient of a straight line, well, first of all let's define what that is. I've defined it as the change in the y coordinate when the x coordinate increases by 1. You might come up with something a little less cumbersome than that, but that's the basic idea. So let's just take a look to begin with at some graphs. So here I've got a graph drawn on this grid, and say I want to find the gradient. Well, I've defined that as the change in the y coordinate when the x coordinate increases by 1. So let's take this coordinate here. Let's take this coordinate here and say that coordinate there is 0, 6. So that coordinate there is 0, 6. Now if I go from 0, 6 along to where 1 is on this graph, 1 on the x-axis is that's going to give me the coordinate 1, 10. So what I could say then about the gradient here is that the gradient of this straight line, the gradient would be the gradient would be 4, because it is the change in the y coordinate when the x coordinate increases by 1. We've gone from 0, 6 to 1, 10. So the x coordinate has gone from 0 up to 1, it's increased by 1, and the y coordinate has gone from 6 up to 10. Now it doesn't matter where we choose on a graph. So say for example I've just chosen to go up by 1, but what if I say went up by, I don't know, let's say go up by 3. So let's start down at this point here. Now I've got the coordinate minus 2, minus 2. So now all that I need to work out is how much the y coordinate is going up by each time the x coordinate increases by 1. So again, the same idea, but we're going to think of it slightly differently this time, because actually the x coordinate, to go from minus 2 up to 1, is actually 3. The difference between the y coordinate when we do this, that's going to be 12. So the difference between the y coordinate is 12, and the difference between the x coordinate is 3. So what I could say is that it is 12 divided by 3. That will tell me how much I'm going up by each time, and so as you can see there, that answer is still going to be 4. So to go up from minus 2 up to 1, I'm moving up by 3. To go up from minus 2 up to 10, I'm going up by 12. And so to work out how much I'm going up by each time I go along by 1 on the x-axis, I can just take the number that I'm going up by, 12, and divide it by the number that I'm going along by. So let's take a look at this example. Let's take 2 points. Say I'll have, let's have this point here. This point here is minus 2, 7. And then let's take another point, let's say down here. My other point here is going to be 2, 1. Oh, not 2 minus 1. Don't know why I did that. 2, 1. And so we can see here that the x coordinate is moving along by 4. So the x coordinate is moving along by 4. The y coordinate has gone down by 6. So what I could say is that the y coordinate has gone down by 6, and it has gone down by 6 in the time that we've gone along by 4. And so what I could say then is that my gradient here is, let's simplify this to minus 3 over 2, and so I could say that my gradient for this one is going to be negative 1.5. And we can just check that now. We can check that by seeing what happens when we move along by 1. Well, so we're at -2 here. We'll go along to where -1 is. And so that would be that coordinate there. Have I gone down by have I gone down by 1.5 on the y-axis when that's happened? Yes, I have, because that coordinate there is going to give me the coordinate -1 and 5.5. So that's the gradient. That's fairly straightforward. The second thing to look at is would be to look at the distance of a line. Now this is just basic Pythagoras. What you'll notice here is if I wanted to work out the distance, say from the coordinate -2, 7 to where the coordinate 2, 1 would be, like all that I've got basically is a right angle triangle where my right angle is in this coordinate. So what I could say then is that this line here, my graph, is the hypotenuse of this right angle triangle, and I'm going down by 6, so I'm going down by 6 and I'm going along by 4. So in order to say work out what the length of this line would be, I would simply just use Pythagoras, so -6 squared plus 4 squared, and then square root that answer. So that would be the square root of 36 plus 16. Run out of space a little bit here. So the square root of 36 plus 16. So the square root of 52. And so then the square root of 52, I could just work that out. And so the length of my line here is 7.2 units. So the length of this line from the coordinate here, -2, 7, to the coordinate here, 2, 1, the distance is 7.2. Okay, let's take a look at 4 examples where we're working these things out. So let's take a look at my first example. Find the gradient of line AB. So let's take a look here. Point A has the coordinate 3, 5. Point B has the coordinate 8, 20. So how far up on the y-axis have we gone? We've gone from 5 up to 20. So we've gone up from 5 up to 20, which is which means we've gone up by 15. And it has to go up by 15. It has taken us. We've had to move along the x-axis. The coordinate has gone. The x-coordinate has gone up by 5. So how far up are we going each time we move along the x-axis by 1? That's going to be 3. So what we could say is that the gradient is 3. So again, just think about that. We've gone up by 15 in the time that we've gone 5 along. So that means that each one that we are moving along is going to be 3. Now the length of the line AB, well, that's just going to be the square root of 15 squared plus 5 squared. And so then we can just plug that into our calculator. So 15 squared plus 5 squared is going to give us an answer of 250, and then we square root this answer. So square root our answer, and so we get an answer of 15.8. So we could say that the length of the line AB is going to be 15.8. Okay, next example. Point A has the coordinate -3, -8. Point B has the coordinate -1, -5. Find the gradient of the line AB. So here we can see that the y coordinate this time, well, we're moving up on the y coordinate. So we're moving up by 3. And in the time that it's taken us to go from -8 up to -5, we have moved along from -3 to -1. So we've moved along by 2. And so now we can say that that is the same as 1.5. And so our gradient is 1.5. So each time we're moving along by 1 on the x-axis, we're moving up by 1.5 on the y-axis. Now the length of the line AB, again just using Pythagoras, we're going to, so we've moved up by 2, so it's 2 squared, moved along, we've moved along by 2, we've moved up by 3, so we square each of those and then square root our answer, just basic Pythagoras. And so then that's going to be the square root of 4 plus 9, so square root of 13. Then we can use our calculator to figure that out. So that gives us an answer of 3.6. So we could say that the length of the line is 3.6. Next one, point A has the coordinate 0, 5, point B has the coordinate minus 2, 0. Question A says find the gradient of the line AB. So again, same idea. How far have we moved along on the how far up or down have we moved on the y-axis? And we've gone from 5 down to 0. So we've gone from 5 down to 0. So we could say that we've gone negative 5 on the y-axis. During that time, what have we done on the x-axis? Well, actually, we've gone back by 2. So we could say that it's minus 5 over minus 2. And so then we could say that that's going to give us a positive answer. Negative divided by a negative. We're going to have a positive gradient. And so that's going to give us 2.5. So I can say that my gradient is 2.5. And then again, finding the length using Pythagoras, we're going to have minus 5 squared, and we're going to have minus 2 squared. Oops, that's not the right thing. Minus 2 squared. Now I'm just putting these in brackets this time, simply because if I was to type this straight into my calculator, I might get a funny result if I didn't put it in brackets. But remember that we're just squaring a negative number. It's going to give us a positive answer anyway. So this is actually negative 5 squared is going to give us 25, and negative 2 squared is going to give us 4. So really we're looking at the square root of 29. Then I can just type that into my calculator. And what do I end up with? I end up with 5.4. So my length, I can say that my length here is 5.4. Okay, final one. Point A has the coordinate 1, 5. Point B has the coordinate 5, minus 7. Find the gradient of the line AB. So again, let's take a look at what's happening to our y coordinate. How far are we moving up or down? This time we're moving down by 13. So on the y axis we are going down by 13. And how long is it taking us to do this? How far along the x-axis are we moving when we're changing by this much on the y coordinate, on the y-axis? And that is going to be 4. And so I've got minus 13 over 4, which then I could say is exactly the same as minus 3 1/4. So my gradient here is going to be negative 3 1/4. And then lastly, find the length of the line AB. In this example, it's just going to be the square root of negative 13 squared. Again, just putting in brackets so that if you are just plugging this straight into a calculator, you don't make any mistakes. And then plus 4 squared, and then that's going to give us, what is that going to give us? 185, I think. So the square root of 185 and so that gives us an answer of 13.6. So square root of 185, and that gives us an answer. So the length is going to be 13.6. Okay, so here are 4 practice questions for you to attempt. What I suggest you do, pause the video, attempt these questions on paper, and then press play again to see the answers, which are coming up now.